Thanks for watching this free video tutorial, which is a free sample from our course Comprehensive Introduction to Arnold 5 for Maya. It is a massive 9-hour long course in which we explore all the aspects of Arnold for Maya thoroughly. Make sure to visit our website mographplus.com and check the entire course out. In this lesson, we learn about Arnold volume. Before starting this lesson, I want you to open your browser and go to openvdb.org/download, and if you come down here, they have these sample models. Go ahead and download these 4 files: explosion, fire, smoke 1 and smoke 2, and extract it on a folder on your hard drive. You can access these OpenVDB files and bunch of other files in the assets folder of the project files for this course. Now, Arnold volume, you can use it to load volumetric files stored in formats such as OpenVDB, which is an open source library developed by DreamWorks Animation, and it is capable of efficiently storing and manipulating volumetric data. I don't want to get into technicality that much here. I just want to show you the workflow and how to use OpenVDB files in Arnold, and hopefully make you more interested in the subject. Now, in this scene, as you can see, we have this simple camera and 3 area lights. The main light is this left light. Then we have these 2 fill lights on the right side and from the top. Let me just go ahead and go to the camera view for now. Now, the first thing you need to do when you want to open an OpenVDB file is to go to the Arnold menu and add an Arnold volume. Okay, now we have this AI volume, and from the file name you can click on this yellow folder, and if you go to the assets folder, go to the OpenVDB folder here, you can see we have this OpenVDBs, and in this case let me just load this explosion.vdb and click load. If I select the volume, I can scale it down so we see this in our view, and let me just also move it a tad so it's centered. Let me select the volume again and go to the shape tab. Okay, now that we have loaded this, you can see this is the file that we have loaded. In the available grids list here, we have all the available channels that this OpenVDB file has. In this case, density, temperature, and velocity. And grids here is a list of OpenVDB grids to read and make available as channels in the volume shading context. So right now, even though we have density, temperature, and velocity grids available in this OpenVDB file, we are only making the density channel available in the shading contents for our standard volume and volume sample nodes. So let me control click the temperature and the velocity, and as you can see, they have been added to the grids list and now they are available in the shading context. In a moment, I'm going to show you how to use these channels to modify the look of your fire and smoke. And the next step would be to assign a standard volume shader to our volume and render the scene. So let me just change this panel to Hypershade. And if I open up the Create window and go to the Arnold shaders and go to the volumes, here we have our AI standard volume. So let me add one and select the AI volume that we have and assign it there. Now we have assigned our standard volume shader to our volume. Let's open up the Arnold Render view, and let me just quickly get rid of some of the toolbar icons that we have. We don't need these as well. Now let's run the IPR and see what we're gonna get. Make sure you are in the right camera. So as you can see, simply by assigning a standard volume shader to our volume and making sure that all the channels are available for the shading context, we are getting this beautiful render of the explosion file that we loaded. In the velocity grids field, you can specify the velocity field to be used for motion blur. It could be one vector grid, like here in this case you would enter V or vel for velocity. Let me click here and select it. Or it can be 3 floats. We have velocity scale, which is a scale factor for velocity field. As you are increasing it, you're gonna have more motion blur, and at 0 you disable motion blur for the volume. Obviously this is just one frame, it doesn't have any motion to get any motion blur, but in this case you had a sequence of OpenVDB files. You can actually take advantage of these velocity options here. just make a bit more space here and select the standard volume shader and take a look at its parameters here. So if you just select this, standard volume is a physically based volume shader. It provides independent control over volume density, scatter color, and transparency color. Also, black body emission here is used to render fire and explosions directly from physics simulation. Each component here can be controlled by a volume channel coming from the volume object, those channels that we made available, with other parameters acting as multipliers on the channel. Now let's take a look at these parameters here. Now to see these density parameters, these scatter parameters a bit better, I'm actually going to make sure we don't have any fire components. And for that, I'm just going to change the emission mode to none. First, we have density, which is the density of the volume with low density resulting in thin volumes. So if I use something like let's say 3, you can see we have this thin render, and high density in thick volume. So if I go to something like 1, we're getting a thicker result. Go to something like 5, even 10. So as you increase the density, you're obviously getting a thicker and thicker volume. We have density channel, which is the density channels to read from the volume object. In the volume object, in the Arnold volume, we had density, temperature, and velocity, and the density channel is being used here. Now we have this displacement parameter here, which you can connect a noise texture or other shaders here to displace the volume, similar to displacement on surfaces. We explain displacement parameter practically when we talk about converting polygonal objects to volumes in Arnold later on in this lesson, but for now let me skip it and come down to the scattering section. We have this scattering weight or scattering intensity, and this is basically controls the brightness of the volume under illumination. If I use lower values, you can see we're gonna get darker and darker smokes. We have the scattering color, which controls the color of the volume under illumination. Right now, we're using this kind of mid-gray value here. And if I use a very bright value, you can see we're basically getting a brighter smoke compared to what we had before. Or we can use a much darker color if we wanted to simulate something like this. And probably if we have our emission, we can create some nice stuff. In this case, let's set the color to a mid-gray color for now. Next, we have an anisotropy, which is the directional bias or anisotropy of the scattering. The default value of 0 gives isotropic scattering, so that light is scattered evenly in all directions. Positive values bias the scattering effect forward in the direction of the light, while negative values bias the scattering backwards towards the light. So as you can see, negative value and a positive value. Probably we can use a lower density here. Maybe use just a tad brighter color. So as you can see, that's with positive anisotropy, and that's with negative anisotropy. Now let me set this to 0 and probably use a bit darker color for the scatter color, or we can just use the default color here. Now this is where you basically control the main color of your volume. For example, if I wanted to have a colorful smoke, I can obviously, let's have this purplish, or so as you can see, simply by changing the scatter color you can achieve some crazy stuff. Okay, get back to around 0.5 here. We have transparency, and here you have additional control over the density of the volume to tint the color of volume shadows and objects seen through the volume. So if we change this to, let's say, another color here, you can see you can get some very fascinating effects. You can see now we're tinting the shadows here, And we have this transparency depth here, which controls the depth into the volume at which the transparent color is realized. So if I increase it to something like 3, you can see how it affects the render here. You can obviously define a channel for the transparency. So if I type in density here, we get a different result. We can type in temperature and get a different result, but in this case we don't need a channel for transparent section of the Arnold standard volume. Then we have this emission mode in the emission section, which by default is set to black body here, and in this mode the volume emits color and intensity based on temperature for rendering fire and explosion. So as you can see, first of all, you have different modes. You can have black body, you can set it to none, you can set it to channel, and then define a channel down here in this channel section. For example, if I use temperature here, now the temperature channel will be used to basically control the emission. And now you can use, obviously you need to use a ramp to control the color exactly, but as you can see, you set it to a channel and then you can set any specific color here, or you can set it to density or the black body, which is probably the option that you want to use it most of the time. Let's set the color back to white here. We have this emission weight, which decreases or increases the overall emission. So if I wanted to decrease the emission, I can decrease the weight value here. We have the color, which is a color to tint or multiply the emission here. So if I use, let's say, a green color, you can get different results. Okay, in this case, let's set it back to white. We have the emission channel, and in channel emission mode up here, the emission channel to sample the emission rate from can be set in this channel section. But in this case, we are going to be using the black body mode. And down here, we have this temperature section. We have this temperature. If a black body channel is used, this acts as a multiplier for the black body temperature. So it's set to 1. If I set it to something like 2, as you can see, we get a much more emissive fire here, probably something like 1.5. We have this channel, and in black body emission mode, the temperature channel to read from the volume object can be defined here, which is probably temperature, and it's set here. We can obviously use something like density, and as you can see, you get a totally different result, but in this case what we are interested in is temperature. We have this black body Kelvin value, which is a multiplier for the temperature from the temperature volume channel. So if I use something like 7,500, as you can see, it's much brighter. Let's go to something like 9,000, 11,000, or we can use lower values, let's say like 2,500, and barely get anything. So you can set the Kelvin value here. And you have this black body intensity, which controls the intensity of the black body emission. So again, you can set lower intensity values down here as well, which is very similar to the weight value up here. Just you have this multiplier controllers in different places. Now, getting back to the Arnold volume itself, if I just come here and select the AI volume, we have a few parameters to discuss, just the important ones. We have frame, which specifies the frame of the sequence to be rendered. If you are rendering an animation and you have multiple frame loaded, and in this case you just want to render one frame of that animation for testing purposes, you can set that particular frame here. You have padding. It's like the bounce padding, if you remember when we were discussing displacement mapping, and it enlarges the volume. And this is useful when displacing a volume with a noise, for example. we have this very important step size parameter which sets the size for sampling inside the volume, and it should be small enough to capture the smallest feature in the volume. And you have this automatic step size which sets the minimum voxel size defined in the VDB as the step size, and can be very, very useful. To clean up your volumes, make sure your lights in the scene have enough volume samples. So if I select my light right now, and if I come down here to the Arnold section, as you can see, we have this volume samples, and they are set to 2 for the 3 lights that we have in the scene. So if you saw any direct noise in your volumes, you can obviously increase the volume samples for your lights, especially this left light in this case, which is our main light. We can increase its volume samples to get a bit cleaner result, even though it's not too bad. If you want to have multiple scattering in your volume, you need to go to render settings and ray depth section and increase the volume ray depth. So if I open up the render setting, ray depth, right now the volume ray depth is set to 0, and this is the render that we are getting. Let me actually save a snap here. Now let me increase the ray depth for the volume here to something like 2 and see the result here. Okay folks, so the render is finished, and if I compare it to our previous render without multiple scattering, you can see we get a much more realistic result. So we done that by increasing the volume ray depth, and this way, as you can see now, the volume illuminates itself and we get this beautiful render. Now if you come up here, we have this volume indirect in the sampling section of the render setting, and this controls the number of sample rays that get fired to compute indirect lighting of the volume. So to reduce noise, when you have more than 0 volume ray depth, you need to increase the volume indirect samples here, probably something like 3, 4 for your final render. So as you can see, this is without multiple scattering, and this is with multiple scattering. Great. I'm gonna just go ahead and actually stop the IPR. Let's rename this to AI Volume Explosion. And now let me quickly get back to the perspective view. Let's talk about volume AOVs. If you remember, when we were discussing AOVs in our previous section, we skipped this. So if you go to the render setting and go to the AOVs tab and come down here, we have this volume AOV. So let me select all of them and add them to the active AOVs list. Perfect. Now let me run the Arnold Render view again, and let's take a look at this AOVs that we have. We have this volume, and this is the beauty AOV that contains only the volume. We have this volume albedo, which is the volume albedo, so any pixel that contains any volume information will be white and the rest will be black. We have this volume direct, which is the direct scattering in volumes. We have this volume indirect, which is the indirect scattering in volumes, and if you have your volume ray depth set to 0, you are not going to get this pass, and it will be completely black. And we have the volume opacity, which is an RGB AOV with the full 3 channels that contains the opacity of the volume. Now let me get back to the beauty pass here, and let me also stop this. Now if I go to the Hypershade panel here again and open up the create window and come down to the Arnold utility and volume shaders here, you can see we have this volume sample node, volume sample float and volume sample RGB. They are very similar in functionality, but the float type has a float output and the RGB one has an RGB output. In this case, let's add a float sample float here. Probably we don't need the create menu. What you need to do is to define the channel from the OpenVDB file that you want this node to sample and then pass the information. In this case, we obviously can use something like density and connect the output here to the density input of the standard volume. You can use these sample nodes, volume sample nodes, to color correct the volume here. You can control the contrast, the bias, input and output minimum and maximum, and so much more. Now if I just come here to my, let me just run the, and let me select the sample float node here. We can obviously go to standard volume. I think we can actually turn off the density here because we have already sampling the density in the sample float node and passing the information to the next node, which is the standard volume. Now if I select the AI volume sample itself, let's see. So we can, as you can see, adjust different values and get different results here. Probably we can add a bit more contrast or decrease the contrast. You can see you can have some fun and create some amazing stuff. You can probably add the bias, maybe increase the contrast a bit. It was too much. Or work with the output min and max. Okay. Let me just actually stop this and let me show you another quick example. So let me in this case hide this and get back to the perspective view and load another Arnold volume. In this case, let's load this smoke.vdb. Make sure the density is available. We can probably enable automatic step size. Get back to the camera and let's run the IPR. Obviously, the first thing we need to do is to assign a standard volume to this newly created volume. I'm gonna just select this and let's probably use an intensity of 2 and assign it to this newly created volume and run the, let's just make sure everything is all right. If I select the standard volume, make sure the density channel here is set to the proper volume. Now we have our smoke. It's really that easy to open up different OpenVDB files and create different effects. Just by adjusting these colors. So as you can see, you can really have a creative control over the look of your smoke and adjust it the way you want. Now the next thing I want to talk about is how to convert your object to a volume and maybe displace it later on. Now let's do that. Actually, I'm going to stop this and quickly go to the perspective view and hide this. Let me just rename this to smoke and hide it. And let's say we create a simple geometry like a sphere here, okay? That gets back to the camera view. And let me just make this sphere a bit bigger, probably something like this. Now to convert a geometry to a volume source, what you need to do first of all is to select the geometry, and if you come down to the Arnold, you have some volume attributes. First of all, you need to make sure the step size is bigger than 0. So let me try something like 0.1, and we are displacing this, so let me add volume padding of 1. Probably a bit too much, but let's see what we can do here. And let's see the resolution gate. So we can probably make this sphere a bit bigger. There you go. Now the next step would be to assign a standard volume shader to this sphere. So let me go to my hypershade panel. Let's create a new one. So a standard volume, and select the sphere geometry, assign it here. And if I get back to my Arnold Render view, let's render this, and as you can see, we have a sphere which has been converted to the volume that we see here. And we can use a lower density value like 0.1, but if we want to see that to be so thick, we can obviously increase the density as we wish, probably change the color. This all can be done. Now let's take a quick look at this displacement option here. So if I want to displace this volume using a texture or a noise, what I can do is simply, let's look for a noise, and in this case let's use the Arnold's noise, AI noise. Select the standard volume and simply drag it on the displacement parameter of the standard volume shader. Connect the out color to displacement and close. Now as you can see, immediately the sphere has been displaced. Now I can select the AI noise here, probably increase the octaves to get a bit more detail. We can decrease the scale to something like let's say 3 to make the noise pattern a bit bigger. Let's set the octaves to 3, maybe amplitude to something like 2. We can probably select the standard volume itself and decrease the density a tad. Maybe let's try something like 0.5. Now as you can see, we have this displaced volumetric sphere, and if I want to get a bit more creative, I can, let's see, add a ramp and add some funny colors here. I don't know, now that we have these colors, we can connect this to, let's say, the scatter color. So you can really play around with this and maybe try assigning these colors to the scatter color of the smoke or the explosion that we had, and create some fascinating stuff for yourself. But I think this is nice and enough for now. Thanks for watching this free video tutorial, which is a free sample from our course Comprehensive Introduction to Arnold 5 for Maya. It is a massive 9-hour long course in which we explore all the aspects of Arnold for Maya thoroughly. Make sure to visit our website mographplus.com and check the entire course out.